Hi, today we are going to be solving exponential equations. The property of exponential equations reads, if b to the x equals b to the y, then x equals y. What this property states or is trying to say is that if the bases are equal, then there's no way around it. Then the powers or the exponents have to be equal. So a quick example. So let's just say we were asked to solve, say, 5 to the x equals 5 to the second power. We can try to do it by inspection, or if we keep our cool and apply the property of exponential equations, I want to point out or notice what is it that is the same. So in this case, the base on the left side is equal to the base on the right side. And the property of exponential equation states that if the bases are equal, then there's no way around it, and the powers are equal. So the left power equals the right power. And this was a nice example where we set the exponents equal to each other, we're practically done. So let's go ahead look at a slightly more challenging problem. So we are asked to solve the following equation. So the first thing I want to ask myself, what kind of equation is this? Is this a linear equation, quadratic equation, and so forth? So I'm going to go ahead see where the variable is. The variable in this case is located in the exponent, so this is an example of an exponential equation. The question is, how are we going to solve it? The first thing I'm going to ask myself is, can I easily fix it so the left side and right side are written in terms of the same base? So I'm looking at the bases. The base on the left side is 4, the base on the right side is 2. So I would ask myself, can I fix it in terms of base 4? Well, not really, because 2 is not a power of 4. But now my next question is, what if we aim for base 2? And in this case, that would be a good idea because 4 is a power of 2. So let me just speak to myself. So we're going to take our time, and our ultimate goal is to fix it so the left side and the right side are in terms of base 2. If we take our time, 4 in terms of power of 2, 4 is the same as 2 to the second power. But what is going on with that 4? We have that 4, and that is being raised to the 5x minus x squared power equals, we already have base 2 on the right side. So we have 2's on the left, 2's on the right, but it's not really quite base 2 because on the left side the base is 2 squared and not 2. So in this case, we are going to apply the power rule to begin to simplify the left side. So the power rule for exponents says this: if we have a factor and we raise it to some power, we are going to keep the base and multiply the exponents. So when we apply the power rule to the left side, we're going to keep the base of 2 and then multiply the exponent. So that will give us 2 raised to the 2 times 5x minus x squared power equals the right side. I think that's called right side. And at this point, I'm going to ask myself, how are we going to handle it? So I want to ask myself, do we have base 2 on both sides? And in this case, we do. So we are going to go ahead apply the property of exponential equations. So the property says if the bases are the same or the bases are equal, then there's no way around it, and the powers have to be equal. So let's go ahead set the powers equal to each other. We take our time, solve it however we like. Let's go ahead and clear those grouping symbols, and then make the call of how are we going to solve it. So we have a degree 2 equation or quadratic equation. You can solve it however you like. You can try to solve by factoring, quadratic formula, complete the square, or whatever technique comes to mind. I like to factor, so I'm going to assume it's factorable until I realize it's not. So if we're going to solve by factoring, let's go ahead set this equal to 0. So we're going to move the 2x squared and the 10x, and that will give us 2x squared minus 10x minus 12. We can either factor a 2, or we can just tone down the numbers by dividing both sides by 2, and we're allowed to do that thanks to the division property of equality. So when we do that, will give us 0 is equal to x squared minus 5x minus 6. And then the moment of the hour, is this factorable? I hope so. So if it is a corresponding x game, we want factors of c that add up to b. Factors of -6 that add up to -5. If we take our time, the factors are -6 and 1, so that will give us 0 is equal to x minus 6 times x plus 1. Then we're going to take each factor, set that equal to 0. So we're going to say either the first factor equals 0 or the second factor equals 0. And that will give us the solutions of 6 and -1. Bear in mind that OR means union, so it would be really nice if you combine your solutions. And it's up to your instructor if the instructor wants to write their answer in set notation or not.